Welcome back. And off we go. Fall 2019. T3, part 4. We've got some review reactions here mixed in with some new reactions. In fact, I think this whole thing is review up to here, the whole deal. But let's quickly do it. Cyanide ion is here. Strong nucleophile backside attack, secondary carbon. Got a reversed stereocenter. We're forming a hydride ion, making H minus. It's attacking a nitrile. Lone pair is going to come up to BH3. You can probably do that all at once if we want. But I didn't notice until right now, so I'm going to do it now. BH3 was created also. We need to put something on the nitrogen so we can attack the carbon again. And we have a group that's not going to change for the rest of the question. R is attached to C with a double bond to N. Now has a BH3. Four bonded boron minus charge. And H minus leaves again. Yes, you need this reaction to happen twice. Now we have a reducing agent for the second reduction. H minus. Going to generate a nitrogen anion. I see we have a no mechanism thing coming up. You can write under the box. Minus BH2. We have two new hydrogens on this carbon. There's CH2. The minus is going to react with HCl, the first HCl. And after that, the sigma bond is going to react with a second HCl. Use the anion lone pair first. It's more reactive. And then the sigma bond from C to B breaks. And now we have a question: how do you convert an alkene to a ketone? And we don't know how to do that in one step. I do know how to make alkenes into alcohols. And I think I'm going to suffer through a 50% yield here. Oh, I don't know how strict I was grading this. If students gave me H2O and H2SO4 in step 1, I'd probably remind them that there would be a rearrangement in that reaction, and you would get, instead of an OH there, you'd get an OH here with a rearrangement. So I would consider this bonus, having to rack your brains back to your past here. But one of the safer ones would be the oxymercuration one. No rearrangements there. The hydroboration one would work as well. And this is just a reward for students who can remember all that stuff. And doing it this way, though, it's going to be 3 steps. H2O, HgOAc twice, water. And step 2 would be sodium borohydride. Hey, that was the original sodium borohydride. And then step 4, you got to oxidize your alcohol to a ketone. Step 4, step 3. PCC takes up the least space in the box. And once again, you get a 50% yield of this ketone and a 50% on the other carbon because they had the same substitution. But that's sometimes the best we can do. And why is this thing in a square parenthesis like this? Oh, it's because it's an intermediate. As soon as you create the ketone, it's going to react with the primary amine to make an, what's that called? That's called an imine. Yeah. Could even make sure it happens faster by throwing a DST in there, but you don't have to. Dean Stark trap because it's a condensation of sorts. Can't truly call it a condensation. This molecule provides both reactants. They do come together, but they're already together. So you can't say it's two things coming together for the first time. Reagents only, no mechanism. How do you reduce an imine? We got a lot of ways. H2PT is one nice way. You could use sodium borohydride for the third time on the same page. That'd be nice. Yeah, sure. Why not? Almost becomes a sodium borohydride review page. And I believe I carried that molecule forward on the next question. Yeah, there was a request to do the next part as well. And the first top of the page sets up a Hoffman elimination. That's what the top of the page is all about. It's got exhaustive methylation. We have room for 2 methyl groups. We made a quaternary ammonium ion, bringing today's lecture full circle. Quaternary ammonium salts. And then we have to do some kind of a precipitation reaction to make silver methyl sulfate here. And we're going to do hydroxide. We have to make hydroxide. It's part of the mechanism here. So the organic portion doesn't change at all here, but there's 2 points. So, you know, I do want the inorganic portion there, right? Those 2 points aren't just going to miraculously appear on your score. Backside attack. It's dimethyl sulfate. You're not too used to it, but it's in industry, it is the most common methylating agent, dimethyl sulfate. And that puts one of your methyls on there. Short forms are going to be difficult, so let's not try. Oh, I need the nitrogen there. How am I going to draw this? I think I'm going to try doing something like this. Yeah. Oh. Yeah, make that a dot. That's a plus. Okay. And that's one of your methyls. And we have to neutralize that so we can do it again. What's going to neutralize that? Well, you made a conjugate base in step 1. OSO3CH3. Anion. Grab H. Sigma becomes lone pair. And what are we going to make? We're going to make this arrow longer. That's what we're going to make. And we're going to try to draw that ring again. Goes to an N. Lone pair. There, did a little better this time, huh? And we're going to do another methylation. I don't have to draw it again, thank goodness. Where's it getting the second methyl group? Well, there's an excess of that dimethyl sulfate. Let's use it. CH3 OSO3CH3. Backside attack, leaving group leaves. Major species over there. The inorganic portion, I mean, you don't have to use old tests to review this. Go straight from the textbook. It's out of the textbook. 100% going to be the same every time. No modifications necessary. O2 minus has to react with water. Yes, we have O2 minus as this anion here. We have water right there. You need to show me this for 1 point. Those arrows are worth a point. You get 2 hydroxides. You don't have to show me stoichiometry, but you made a hydroxide. That was one of the changes that happened going from here to here, right? The other change is you need to make me a precipitate with this anion and the silver. So you guys have to draw it out on the test. So I'll draw it out here too. Ag plus. Huh. That reminded me of something. Ag plus reacts with sulfate ion that has a methyl on one end. Yeah. Just single arrow. Get a point for that arrow. That's how you make your precipitate. Right there. And there's 2 points. 1, 2. And the rest, you don't have to draw any more organic molecules. That's the good news. We're going to use hydroxide to do elimination reactions. So 1.33 points each. That's a strange score. I guess I wanted it to equal 4. Okay, so you got to pick the right hydrogens, everybody. How do you get from here to here? Where's your double bond end up? It needs to be from this carbon. Let's just highlight them. Double bond ends up from this carbon to this carbon. Here, the double bond ends up from this carbon to this carbon. I hope you're noticing one of the highlighted carbons has to be the carbon attached to the nitrogen because the nitrogen's the leaving group. And the last double bonds from here to here. This should help you pick the right H's, everybody. On the product, this carbon here is this carbon here, right there, has no H's here. It had an H here. This was CH2 to begin with. It's CH2 to end with. No change there. That's just leaving group leaving. So it looks like the beta carbon needs to have an H on it. Well, you know it does. Okay. That was not the computer being persnickety. That was the pen saying you haven't used me in a while. H there and H here and H right there. Lone pair on the hydroxide needed every time. Some of you know what happens if you don't show the lone pair. You lose a 1/4 point. The reason is there's no electrons in a nucleus, and if that lone pair is not showing, I'm assuming you're trying to draw a lone pair from the nucleus, which is a mystery. Unicorn, I should say. Okay, I'm not explaining what I'm doing here. You're losing an H from the beta position. Beta being 1 away from the carbon with the leaving group, which is the alpha position. Lose an H from there, make a pi between beta and alpha. Here, beta, 2 away, 1 away, alpha. Hydroxide grabs H. And same story at the bottom. And sigma becomes pi. Leaving group leaves, and we're not quite done. Got some splaining to do. And the question is for the major one, which we haven't circled yet, which H was easiest to get at? It's a good question. Which H was easiest to get at? Well, that's a tertiary carbon there, losing an H. That means there's 3 carbons attached. Here's a secondary carbon losing an H. That means there's only 2 carbons attached. That's less hindered, means easier to approach. Back downstairs, tertiary carbon, hardest to approach. So here's the circle, and we'll put the words down and call it a day, unless there's something else we have to talk about. The H is less Hindered. I don't know. Is that really worth 4 points? I got an explanation and circle worth 4. I think it's worth 3 at most. 1 for the circle, 1 for acknowledging it's about H and approaching and using the word hindered. 3 points. And I think we covered all the parts in this question. It's good. And do you have any last minute questions before we part?
Yes, I do have a question.
Sure.
It's about the layout for the test.
The owl?
No, it's
Oh,
about
the layout. I'm sorry,
yeah.
layout. Sorry. Yeah, I hear you now. Yeah, what about the layout? I sent it
So
earlier, just before class, so you didn't have time to look at it too much.
there's you said like there's gonna be a questions like cut the numbers of boxes in half. What's that?
Oh, it'll be the same type of question, but you won't be asked that many versions or that many parts.
Oh, okay.
Yeah, so yeah, all semester we've been trying to cut the tests basically in half, right?
All right. Yeah.
So you never have as many versions. The question will look like that question, but it'll be half as many points and half as many boxes. No boxes for
Sure.
you. You're gonna just tell me what A and B and C are, right?
Yeah.
Okay. So we're
Yep.
good. Think of lots of good review questions before Monday. But once again, your problem set, I'm going to try to post it tomorrow because I know the more time you have to work on it, the happier you guys will be. So I'll try to post your problem set tomorrow. I'll send an email the moment I post it, and you'll have till Sunday at 11 o'clock to have that finished. And I sent an email earlier today about your problem sets have enough mechanisms to cover your mechanism journal for the whole semester. So that's why we haven't been doing journals. And once again, that was motivated by a student asking a good question about journals. And thank you for asking that question. And I will see you all Monday. Take care. Bye-bye.